Hey everyone, it's Teepa. And it sounds and seems like at least some people found the article I did in the journal this month on the limbic system to be helpful. And some people actually asked for a little bit more. So I thought I'd sort of share with you my original article, which was a bit longer and a lot more involved. Help from Dan and Jason, our editors, got it down to a more reasonable size and probably a more understandable format. But for those of you who are curious about what exactly it was I was trying to convey in greater depth and in greater detail, I thought maybe I would share with you the original article with all its flaws. But I thought I'd read it out for you and maybe share a couple of pictures at the end, so that you get a chance to see how my brain works and then how people help my brain work when I'm trying to share things sometimes on first draft. So if we want to understand the strengths and the skills of our non-cortical brain, not the cortex, our central nervous system is composed of actually many parts. One basic way to divide it is into three functional parts: our primitive brain, very primitive, our limbic system, and our neocortex. In other words, the rhythm of life and pain, pleasure, reactive brain inside of us, and then our survival and stay alive in the world kind of brain, and our think it through and negotiate it for the long run kind of brain. Or in fancy neurological terms, our hind brain, behind, the midbrain, middle, and the forebrain, top part. But if only it were that simple. Actually, our neocortex, we consider the thinking and the aware, active processing part of our CNS. And in many ways, it's the most developed and typically the most valued in our brain as adults. And yet, it's actually the last part that actually forms in human beings. In reality, we have to first develop and figure out how to use our primitive brain and then our limbic brain sections. And once we get those online, then we can move forward into learning and getting our higher order systems online and going. That cortical brain is actually more of a luxury item, not essential to the survival in a minute-to-minute type situation framework. And our ability to effectively use our neocortex depends on the integration and the well-being of those primitive brain and limbic system components. So the core structures of the brain actually form as a human being is developing from an embryo into a ready-to-be-born baby. And early in brain formation, the system for running the basic rhythmic functions of the body are established, and they're formed, and it's the medulla oblongata, Latin, medulla oblongata. And this part of the brain stem, because it's down and in the stem of the brain, controls heart rate and respiration. And as that portion of the brain develops, we start to see the pons, which is a section, and the cerebellum, which I talked about last month or the month before. These two areas are actually vital to survival of the baby on the outside of the mother's womb. And the pons serves as a link between sort of the cerebellar area and the medulla oblongata area and some other places. It links the medulla oblongata with the thalamus. And the thalamus is that really important part in your brain of linkages, wiring connections. And the cerebellum serves as a major processing link between the spinal cord, the medulla oblongata, cranial nerves, most of them, and the brain, the cortical brain. And I talked about that cerebellum in May's journal. So it may be worth taking a look at that if you're more interested. The thalamus actually serves as a major relay junction for getting sensory info into the brain from the body, from the various sections inside and outside of the body, and for the perception of discomfort and pain. Therefore, the pons and the cerebellum are both very active in pain reactions and changes in heart rate and breathing rates. When sensory data is perceived as problematic or painful, they change us. And they also have pathways and connections that perceive and react to pleasurable and positive sensory and enjoyable stimulation. And as the brain continues to develop in the fetus, still inside the mother, the midbrain structures are formed then. And this section serves as a processing area and connector between the basic survival brain structures and the thinking, or the beginning of the cortical brain structures. That prefrontal, the frontal, the parietal, the occipital, the temporal. And so this section serves as the processing center and a connector between the basic survival and the thinking, or cortical brain structures. It's frequently referred to as our reticular activating or our limbic system more globally. And it's a primary player in controlling attention, what you pay attention to, and interactions with auditory, visual, tactile experiences, as well as like wake, sleep, hunger, thirst, elimination, temperature regulation, infection control, immune reactions, and other very complex and interwoven life support systems. Its all-over goal is actually to maintain a healthy balance, or what's called homeostasis, with some reserve, like wanting to keep a little bit in the bank for emergencies. And what it includes is the amygdala, which is that threat perceiver, needs meter, and pleasure seeker. The hippocampal areas in that brain part, where it's where you learn and remember and you find your way from place to place and how to get back to the original location, and keeping up with how much time has gone by since you last. And then the thalamic connections. Now I mentioned the thalamus, the thalamic connections. This is how you get your active sensory messaging in, and emotions of distress or excitement happen through that thalamus. The hypothalamus is critical in things like temperature regulation, blood sugar regulation, wake-sleep cycling, circadian rhythm, fluid balance, sodium regulation, and endocrine hormone firing. Whoa, pretty important. And then pineal glands, pineal glands, pineal glands, or pineal glands, depending on who you hear talking, it sort of controls how much melatonin is produced. So they're really critical in that wake sleep thing. Mammillary bodies, they have a role in memory formation and interest in the world and data, and these are all part of this limbic system. And then we have the septum, which influences anger, fear, sadness, those negative emotions. And we have selected tracks for the olfactory, smell, and the optic, vision, and cochlear, hearing and balance, cranial nerves. So those cranial nerves are critical for survival, it turns out. And then we have pathways to control eye movement and head orientation and positioning, because you certainly want, when you turn your head, to be able to find what you're looking for. And then the corpus callosum, that's that white wiring from side to side that gets your left and your right and your core working together. So at the end of the program, I'll show you this picture that I found online and the link that I think is sort of helpful, which shows the development. Oh, actually, maybe I should just show it now. What the heck? I forgot I could share my screen here. Duh. So what I'll do is share my screen for just a second. Now, this is the picture I was talking about. I'll see. Maybe I can make it bigger. Maybe I can't. Oh, it'll probably just be fuzzy. But if you're interested, here's the website where you could find this picture if you're really curious and want to learn more. So this is embryo, fetus, small child at birth. Wow, look at that, man. That's a lot of development. Sort of cool. Anyway, if you're interested, you can look it up. So what comes next? Well, if a baby is born prematurely, it's going to struggle to survive and will require special supports to transition from life in the womb to life in the world. Whereas before birth, nourishment and hydration was provided via that umbilical cord. And now nourishment and hydration have to be taken in through the mouth, digested through the stomach, into the small intestine, through the large intestine. Kidneys have to do their thing. Waste products have to be eliminated through the ureters, to the kidneys, to the bladder, to the ureter, to the out, or to the anal opening from that large intestine to the rectal vault. And holy moly, that's a lot of shifting. And we have blood. The heart has to actually get that oxygen into the lungs and out. And before, all they had to do was have the amniotic fluid go through the lungs, and they weren't dealing with air at all. And suddenly they have to deal with oxygen. They have to get air in, pull out the oxygen, into those little alveoli of their lungs, and they have to put out all the CO2, get it out, get that to be breathed out, and then the blood has to be picked up and pumped through the circulatory system. And this is actually really complicated. Additionally, the warm and the temperature regulated by the womb isn't happening anymore, and the newborn has to auto-regulate. They have to learn how to regulate for this external world around them, their temperature, the changing environment. There's lots of sounds that are happening immediately and no fluid and nothing to cushion. And so sounds and textures and sights, wow, very, very different. Additionally, it's a huge shock to the system. And classically for babies, it's pretty threatening. And so that's why they scream out, which is a good thing because it fills their lungs with air and gets them going. They used to turn them upside down and smack them, which seems a little extreme. And we don't do that anymore. We put the baby on the mother's lap and then we suction out. I mean, we've changed because we understand it's threatening enough. We don't need to make it worse. We do want them to, and so stimulating by rubbing. Stimulating by rubbing. Hand contact. Oh, oxytocin, here it comes. One very active chemical that's produced at birth is actually cortisol for the baby, which is why we need oxytocin as soon as we can. Another set of chemicals racing around at birth, catecholamines. And these chemicals are produced by the adrenal glands, which sit right above your kidneys. And under that direction of that distressed brain at birth, because it's pretty stressful, they produce this cortisol. They produce this chemical that jumpstarts the engine, and these catecholamines, they jumpstart it. They kick it into high gear, and then they include dopamine, endorphins, and norepinephrine, also called, when you put them together, adrenaline. Baby needs adrenaline to get going, and it's having to react to an outrageous amount of change in the environment and the situation. And frankly, you can't go back home again. Nobody's letting you back in. And so it's a good thing there's at least one or two people out there who are chemically prompted and prepped to take on the responsibility of this newborn survival, because they can't do a lot yet in the world. The brains are actually preparing them, those parents, those people, for the care and the comfort of this new life, much to the discomfort of their own. For them, the production of the chemical oxytocin, in addition to the adrenaline cocktail, is enormous, and it's powerful, and it encodes a caring relationship, a need to give the new one among them a joyful desire to connect and to stay connected and to help to seek to comfort and take care of that baby and make sure it's warm and safe and comforted. Thus, the limbic system sets us up as a communal and giving people who are more complete as a group than we were as individuals. The new you, separate from me, becomes we, and a new tribe of people are formed. And throughout our life, our limbic system and primitive brain will always be very active in the role in what we do and how we do it. Our neocortex is really designed to help us recognize the value and limitations of those two systems, those more primitive systems. But a healthy neocortex really learns how to pay attention to the signals that are coming from those players and not be overwhelmed or immobilized by the messaging unless it makes sense in both the immediate situation as well as the long run. So when a neocortex is not well wired into the limbic system and the primitive brain has errors in metabolism, then errors in metabolism, errors in sleep patterns, apathy, under consuming of food or liquid can take place. And without a well-integrated and actively engaged three-part partnership, the human being that is housing all those brain systems will find that life is distressing, survival is risky, and that which should be helpful sometimes seems dangerous or unnecessary. So finding ways to activate our own or someone else's limbic system in a positive and effective manner can really significantly change how life is lived for both of us or all of us. Small shifts and small changes in smells and visual cues and environmental features, auditory signals, maybe the pace or delivery or the expectations that alter hormones really can affect which cells get fired, which action will be taken or not taken. So, for example, parents who recognize that the meltdown in the middle of the grocery store may well be due to the need for a nap or the need to have a bowel movement is much more likely to make future plans to get those unmet needs met or take them into account when you plan an outing or when you are trying to respond to distress in the moment. When the parent's able to help the child notice their state of distress by making an accurate statement about what emotion is being felt, and then providing some simple options regarding causation, there's a much greater possibility the child can start to build the wiring from the primitive to the limbic to the lobes of the neocortex. So you're mad. Yeah. I wonder if you're tired. No, I'm mad. Okay, you're mad. You're mad at me right now. Yeah. I hate that. Me too. I love you. I love you, babe. I don't like it. Yeah. So then we can start talking about it. And as the child becomes more self-aware and more able to recognize the signals of fatigue or bowel discomfort in advance of acute distress, gradually they start self-regulating and they start managing their own systems. They start advanced planning. And that's what wiring your brain together is all about. So what does this have to do with the world of dementia? Well, overall, brains tend to fail in the opposite way they develop. And it's interesting to note, however, that there are different ways that brains can fail. Sometimes it's important to recall that without an override system, the midbrain and the primitive brain can actually trick us into focusing on what's lost versus what's still working well. And we don't celebrate the functions of the limbic system and realize, well, without the cortical override in place, the person can't get the midbrain to fulfill its role or the primitive brain to stay on the job. It's not because they're not trying, it's because part of the brain isn't working well, part of the brain is working. And then what we can figure out is we can be more tuned into the probability that many of the message we think we're sending to our partner may not be received or interpreted in the way we had hoped. So humor may not feel humorous. It could feel like a judgment, even though it's like, what are you doing? We didn't mean it to sound like, what are you doing? Like a judgment, but it came out that way for the person. It's even possible our efforts to help or the way we offer assistance might get perceived by the person living with dementia's limbic system as a threat or something dangerous or something to be avoided at all costs. And in our effort to try to use our neocortex to help another neocortex that malfunctions, we're making a huge mistake. And we use some non-helpful old parenting or old discipline patterns that worked with the developing brain of a child or a teenager, or maybe they never even worked there. But if we pause and we realize that's what we did worked, if it worked because of the authority relationship we had, we may want to consider alternate pathways because the brain connections aren't the same, because they may actually be increasing that negative affect or the emotions that intensify in the relationship that doesn't feel like it's the way you think it is and the way I think it is. We might be more helpful if we could make some changes to the environment, to the schedule, to our behaviors, rather than asking what's not possible for the person living with dementia. So strategies that catch more flies, or it's easier to skin a cat. Well, you know, those two sayings, which are always interesting sayings if you think about them. However, sometimes opting for the pleasure and the play and the humor and the lightening the load through empathy and supportive cueing might be a more brain smart intervention than trying to get wiring to form and refire in a dying brain. Maybe using empathy and assessing for the possibility of unmet needs could go further in helping all parties with less distress and improving the limbic and primitive brain fitness for longer. Oh, and there's one more thing to consider. There's one more system out there that has a potential role in our ability to support and to help ourselves and others in the world of dementia, and it's called the Reticular Activating System, RAS. It has portions of its structure that are lying in the primitive brain, some that lie in the limbic, and it has wiring up into the neocortex. Context, well, both. And all of our senses except smell have connections to this. It's a tiny little finger-shaped set of structures in the brain. And the reticular activating system is a filtering system. It actually serves as a filter, sort of like the kidneys do for your blood. And no, yeah, for your blood and your urine formation. Yeah, kidneys are real important, and so is the reticular activating system. This filtering system, it helps you ignore some data and details that aren't really helpful or important and pay attention to information that is. It turns out that there are a few items that almost always get through the filter, no matter what else is going on. One is your preferred name, your first name, the name you were given at birth, or the one that you like to be called by. And another one is a sense that you or someone you care about deeply is in danger. Both alert you and divert you from almost anything else when they occur. And an interesting finding is that you can provide direction to your reticular activating system. So it always pays attention to name and danger, but you can also tell it what you're interested in finding, and it will help you keep looking for, listening for, or feeling for that selected stimuli to match what you're seeking. So if you can direct your attention somewhere, it turns out that as soon as you start doing that, your reticular activating system takes over and says, oh, I see it again. Oh, I see it there. Oh, look over there. So it's picking up on what you direct it to go pick up on. So the good news is that you can self-direct and self-talk yourself into better places, spaces, beliefs. You can come out of dark moods. You can actually come out of the dark. The bad news is you can spiral yourself into those dark places or repeated unpleasant experiences and situations. And once you see them, and then they're everywhere and everything is awful. Well, that's not particularly helpful in the world of dementia. The awful is there, but if that's all we're looking at, that's all you're going to see. So knowing that the limbic system and the primitive brain are critical to one's survival, and that also our ability to develop and use our thinking brain may help us let go of the idea that we can get someone to manage their behavior once their brain begins to die. Maybe if we could get that. Maybe it's our own ability to use our complicated three-brain system, and we can use that to produce less challenging, more understandable, more livable, and maybe for the people we care about and love, better life. In order to do that, however, we're going to have to remember to do it for ourselves first, so we'll be able to do it for somebody else we really care about. So that's my expanded version. I don't know if it was helpful. I don't know if you found that, yeah, oh, that was actually kind of cool. If so, great. If not, well, you know, I'm sorry I bothered you, because I wasn't doing it to bother you. What I was doing it for was because some folks had asked for it. So if you find it helpful, please like it and share it, or let us know at least that you did find it to be beneficial, because frequently I actually do more behind the scenes than ends up in the journal. I know my posts may seem really long anyway, but it turns out there's a lot to be learned about this thing we're doing. And human brains, they're a real challenge. I have to go research stuff before I can do those articles. It's so much easier if I didn't. I wish I were brilliant, but I'm just me, doing the best I can. And you too. But if we use our brains, we might be able to make a difference, one mind at a time. Thanks, everybody. I appreciate your attention and your interest. Reticular activating, limbic, primitive brain. Think about it.